Hi friends, in this video you are going to learn about how to solve the numerical problems based on mole concept and molar volume. So in the previous video you have already learned about the mole concept and molar volume. So you know that a mole is the amount of substance that contain Avogadro number of the particles, that is equal to gram atomic mass or gram molecular mass, and it is equal to the molar mass of the substance. You also know that molar volume is the volume occupied by 1 mole of any gas at STP, that is equal to 22.4 liter, and it contains the Avogadro number of the particles, and its mass will be equal to its molar mass. Okay. Now based on this you learn about how to solve the problems. So happy learning to all of you. So consider this problem. Calculate the A, number of moles, B, number of atoms present in 100 gram of the sodium. Now in this problem there are two parts. In the first part you have to calculate the number of moles of sodium atoms present in 100 gram of the sodium, and in the second part you have to calculate the number of the sodium atoms present in 100 gram of the sodium. Now let us take the first part. So for calculating the number of moles, you must take into consideration of the gram atomic mass of sodium, which is equal to 23 gram. So 23 gram is also the molar mass of the sodium. So 1 mole of sodium equal to 23 gram, or 23 gram of sodium equal to 1 mole of sodium atom. So 100 gram of sodium equal to how many moles? So the number of moles of sodium equal to 100 divided by 23, that is equal to 4.35. Okay, so 4.35 is the number of moles of sodium present in 100 gram of the sodium. And dear friends, in this problem we have divided 100 with 23. So 100 is nothing but the given mass of the sodium, and 23 is nothing but the molar mass of the sodium. So if you divide the given mass in gram with the molar mass, you will get the number of moles. Okay, so remember this formula. Number of moles small n is equal to given mass in gram small m divided by molar mass capital M. So small n equal to small m divided by capital M. There is a formula to calculate the number of moles. Now we shall take the second part. So in the second part of the problem, you have to find the number of the sodium atoms present in 100 gram of the sodium. You know that molar mass of the substance contains Avogadro number of the atoms. So here 23 gram of sodium contains 6.022 into 10 power of 23 sodium atoms. Therefore 100 gram of sodium contain how many sodium atoms? So number of sodium atoms is equal to 100 into 6.022 into 10 power of 23 divided by 23. This is equal to 4.35 into 6.022 into 10 power of 23. Okay. Now here 4.35 is the number of moles of sodium that we have calculated in the first part of the problem. Now this number of moles 4.35 is multiplied with the Avogadro number 6.022 into 10 power of 23, which will give the number of sodium atoms present in 100 gram of sodium, that is equal to 2.61957 into 10 to the power of 24. Okay, so in general you can consider this formula to calculate the number of the atoms present in given mass. Okay, so the number of atoms present in given mass equal to number of moles into Avogadro number, that is equal to small n into capital Na. Now here small n is the number of moles and Na is the notation for Avogadro number. Okay, now next let us take the second problem. Calculate the number of moles for 1.806 into 10 power of 24 helium atoms. Okay, now here for this you have to consider 1 mole of helium. So 1 mole of helium atom contains 6.022 into 10 power of 23 helium atoms. that is 6.022 into 10 power of 23 helium atoms are present in 1 mole of helium. Therefore, 1.806 into 10 power of 24 helium atoms are present in how many moles? So the number of moles of helium equal to 1.806 into 10 power of 24 into 1 divided by 6.022 into 10 power of 23, that is equal to 2.99. Okay, so 2.99 is the number of moles of helium that is containing 1.806 into 10 power of 24 helium atoms. Okay, so in general, number of moles equal to given number of particles divided by Avogadro number. Okay, so in this problem what we have done, we have divided the given number of particles, that is 1.806 into 10 power of 24, with the Avogadro number, that is 6.022 into 10 power of 23, and that is giving the number of moles. Okay, so remember this formula, number of moles equal to given number of particles divided by Avogadro number. Okay, now we shall go ahead with the next problem. Calculate the mass of 2.4088 into 10 power of 24 water molecules. Okay, now here we have to consider the 1 mole of water, which is equal to gram molecular mass of water, that is equal to 18 gram. Okay, so 18 gram is the gram molecular mass of water, that is containing 6.022 into 10 power of 23 number of water molecules, or 6.022 into 10 power of 23 water molecules are present in 18 gram of water. Therefore, 2.4088 into 10 power of 24 water molecules are present in how much gram of water? So mass of 2.4088 into 10 power of 24 water molecules equal to 2.4088 into 10 power of 24 divided by 6.022 into 10 power of 23 into 18, that is equal to 4 into 18, that is equal to 72 gram. Okay, now 72 gram is the mass of water containing 2.4088 into 10 power of 24 water molecules. Okay, now in this problem we have divided the given number of molecules with Avogadro number and then multiplied with molar mass. So this will give the mass of the substance containing the given number of the particles. Okay, so in general you remember this formula, mass of given number of particles equal to given number of particles divided by Avogadro number into molar mass. Okay, so next let us go ahead with the next problem. Calculate the number of molecules of carbon dioxide present in 11.2 liter of carbon dioxide at STP. Okay, now for this you have to consider the molar volume. We know that molar volume is the volume of 1 mole of any gas at STP, that is equal to 22.4 liter, and it will be containing Avogadro number, that is 6.022 into 10 power of 23 molecules, and it will be equal to the molar mass. Okay, now here if you consider 1 mole of carbon dioxide at STP, that also occupies 22.4 liter, and it will be containing 6.022 into 10 power of 23 carbon dioxide molecules. Okay, so you know that 22.4 liter of carbon dioxide contain 6.022 into 10 power of 23 carbon dioxide molecules. Therefore, 11.2 liter of carbon dioxide contain how many carbon dioxide molecules? So the number of carbon dioxide molecules in 11.2 liter equal to 11.2 into 6.022 into 10 power of 23 divided by 22.4. This is equal to 3.011 into 10 power of 23. Okay, now in this problem we have divided the given volume with the molar volume and then multiplied with the Avogadro number. Okay, so that is giving the number of molecules present in the given volume of the gas. Okay, so in general you remember this formula, the number of particles present in given volume equal to given volume into 6.022 into 10 power of 23 divided by molar volume, or given volume into Avogadro number divided by molar volume. Okay, now next let us take the next problem. calculate the volume occupied by A. 48 gram of methane gas, B. 4 moles of methane gas, C. 1.8066 into 10 power of 24 molecules of methane gas at STP. Okay. Now in this problem there are three parts. In the first part you have to calculate the volume of 48 gram of methane gas. In the second part you have to calculate volume of 4 moles of methane gas. In the third part you have to calculate volume of 1.8066 into 10 power of 24 molecules of methane gas at STP. Okay. Now for this also you have to make use of the molar volume. So you know that molar volume is the volume of 1 mole of any gas at STP, that is equal to 22.4 liter, and it will be containing the Avogadro number of the molecules, and it will be equal to the molar mass. Okay. Now if you consider the 1 mole of methane gas, this also occupies 22.4 liter at STP, and this also contains 6.022 into 10 power of 23 methane molecules, and it will be equal to its molar mass. Okay. So with this background we shall take the first part of the problem. So you know that 16 gram of methane occupies 22.4 liter at STP, because 16 gram is the molar mass of the methane and 22.4 liter is the molar volume of the methane gas. So 16 gram of methane occupies 22.4 liter at STP. Therefore 48 gram of methane occupies how much volume? So volume of 48 gram of methane equal to 48 into 22.4 divided by 16, that is equal to 67.2 liter at STP. Okay. So dear friends, in this problem we have divided the given mass of methane with the molar mass and then multiplied with the molar volume. So that is giving the volume of the given mass of the gas. Okay. So in general you can remember this formula. So volume of given mass of gas equal to given mass in gram divided by molar mass into molar volume. And you know that given mass in gram divided by molar mass is nothing but the number of moles. So this number of moles is multiplied with the molar volume, and that will give the volume of given mass of the gas. Okay. Now remember this formula. Okay. Now take the next part of the problem. You know that 1 mole of methane gas at STP occupies the molar volume, that is 22.4 liter. So 4 moles of methane gas at STP occupies how much volume? Okay. So volume of 4 moles of methane gas equal to 4 into 22.4, that is equal to 89.6 liters. Okay. Here the volume of 4 moles of methane gas at STP equal to 89.6 liter at STP. Okay. So volume occupied by given number of moles at STP is equal to given number of moles into molar volume. Okay. So if you multiply the given number of moles with the molar volume, it will give the volume occupied by the given number of the moles at STP. Okay. Now next let us take the third part. So we know that molar volume of gas contain 6.022 into 10 power of 23 molecules, or 6.022 into 10 power of 23 molecules of methane occupy 22.4 liter at STP. Okay. Therefore 1.8066 into 10 power of 24 molecules of methane occupy how much volume? Okay. So volume occupied by 1.8066 into 10 power of 24 molecules of methane at STP is equal to 1.8066 into 10 power of 24 into 22.4 divided by 6.022 into 10 power of 23, that is equal to 2.99 into 22.4, that is equal to 66.976 liters. Okay. Now in this problem we have divided the given number of molecules with the Avogadro number and then multiplied with the molar volume. Okay. So in general you can remember this formula, that is the volume occupied by a given number of molecules equal to given number of molecules divided by Avogadro number into molar volume. Okay. So I hope you have learned about how to solve the problems based on the mole concept and molar volume. Wish you all the best.